Person said, I'm Nicola Bice, and I'm here on behalf of my Capstone team, the Collegiate Wind Competition. My team members are Raymond Benner, Trey Bright, George Funk, Brady Monroe, Nathaniel Ray, Laith Reyes, and Jacqueline Rutherford, and a huge thank you to our Capstone advisor, Dr. Holland, who's been a really great help and a huge source of information for the entire project. So let's get into it. First off, what is the CWC? Now, before we talk about the Collegiate Wind Competition, it's first important to talk about renewable energy. The need, demand, and growth of renewable energy has been dramatically increasing since the beginning of the century. And just to take Virginia as an example, they just recently passed legislation that would allow for the planning and construction of offshore wind farms throughout the state. And now this is just one example of what one state is trying to do to try to make a push and a change for how we actually acquire new energy. Now, what this has actually led to is a huge demand for professionals in the renewable energy sector and specifically wind energy. Now, with all of this increased interest, two organizations saw a great opportunity to really increase and grow the field even more. The Department of Energy and the National Renewable Energy Laboratory first created the Collegiate Wind Competition in 2014 with the intent of preparing college students, not just engineering students, to the wind energy sector. So let's talk a little more about the competition itself. Since its creation in 2014, the CWC has evolved to encompass 13 different universities across the nation. Once our JMU engineering team goes to compete in the 2021 competition, it will be our fourth consecutive year competing. However, it's not just an engineering team that's involved in the competition. We are also working with a JMU ISAT team whose primary responsibility is citing and gaining knowledge on where our potential wind turbine would actually exist, as well as working with a third JMU team, a JMU business team, whose primary responsibility is finding and designing a business plan and model for the wind turbine itself. Now, while there is collaboration between the three groups, how we're ranked and how the competition affects us is quite different among the three. For us specifically as the engineering team, there are three main categories we're able to acquire points from: mid-year milestones, a technical design report, and lastly, a turbine performance testing category. Now, each of those have their own subset of requirements to obtain points from, and obviously the more points you get, the higher you score in the competition. Now, while also trying to achieve that, we also have to fit our wind turbine in certain regulation and rules set by the DOE and the NREL organizations. So that leads us to our design focus for the project. As a team, we've identified two different design focuses and two scopes that we really want to factor in. First, you have a competition aspect. Now, we know it's not really going to be possible or feasible to score perfect in every single category when it comes to how well the turbine performs. And that's just simply due to the trade-offs made by a wind turbine. For example, you can't score high in power acquisition and performance efficiency while also scoring high in another category such as cut-in wind speed. And that's just due to how wind turbines operate. Now, with that in mind and multiple trade-offs like that across the entire competition, it's important for us to see what we want to really maximize, what we really want to focus on, and what we are going to have to sacrifice to see what kind of maximum points we can score. Now, the second scope is a little more personal. As engineers and as an engineering team, we really want to push ourselves. It could be really easy to just look at what past winning teams have done, copy a similar model, and just try to execute it, but that's not something we want to do. We really want to take our skills, our new knowledge, and everything we've learned thus far, and really try to apply it to this program, to this project, and really just try to make a wind turbine that's unique to us. See what kind of novel ideas we can actually come up with, and see how well it can actually compete against our fellow competitors. So what's unique about this project? Well, for me, one of the reasons why I was really interested in joining the CWC Capstone was just how many different engineering disciplines are involved, from mechanical, electrical, aerospace, and even computer engineering. All of those give us a unique opportunity to really grow our skills and gain in-depth knowledge on every single engineering discipline. So at the end of the 2 years, we can really see what we enjoyed the most. And even if we realize we didn't really enjoy those disciplines as much, we now have crucial information on what we want to do in our future careers and just have overall more knowledge about what we want to do as engineers. Next, one of the greatest aspects of it is you're really able to go through the entire engineering design process from start to finish. We started off this entire year with, defining the problem and coming up with prototypes, and we're going to end it with being able to test the final design. And that's just a really unique aspect and naturally just makes it really hands-on and really is a great way to end our 2 years as JMU engineers. Lastly, there's the competition aspect. Apart from just being able to compete against, academic peers from other colleges, being able to directly represent JMU with a project that you've put a lot of effort in and a lot of hard work brings a great sense of pride to our school and really is a great source of inspiration for the project itself. So what have we done within this last semester? So we've come up with two different things. So far, we've come up with a really critical subsystem on the left, the yaw system. And essentially why this is important is one of the categories that's going to be required for the actual testing of the wind turbine is how well it's able to stay in line with wind speed. The bottom plate that the wind turbine stands on is going to be is going to rotate 360 degrees. And obviously, if your turbine isn't able to face the wind head on, you're going to lose power in your power efficiency and obviously thus lose points. Now, another category and some calculations that we have run are withstanding high wind speeds. Safety is a major concern for us and a major concern for the CWC. So we've run some pretty quick calculations on seeing what kind of stress the wind tower will actually face. And if we get these, so, focus on some of the other really important subsystems. So what's next for us? Obviously, every team now is facing the same challenge. How are we going to progress in our capstone with the new circumstances that we are facing? Now, our original plan was that after spring break, we were really going to get the ball rolling on some of our more important subsystems, such as the blades of the turbine and the generator of the turbine. We had multiple concepts ready to go after running them through multiple simulations and models. But now with this extended break, you could say, we're taking a step back and we're really going to try to analyze new concepts, look through our old concepts, enhance our models and simulations for the reason to really just try to gather more information, see what kind of trade-offs are going to need to be made, as you can't really build the generator without taking into effect what the blades will do and vice versa. They need to be built in unison, otherwise the overall efficiency of the wind turbine really isn't going to be good, and you're not going to be able to really, it's not going to perform as you originally intended to. So we're going to take a step back and really try to focus in on that. So that's all I have for you today. Thank you so much for your time, and please feel free to ask any questions. Thank you.